Good morning. Today we are discussing causal RAG, integrating causal graphs into retrieval augmented generation. The core challenge we address lies in how LLM handle complex knowledge-intensive questions, particularly those involving causal reasoning, the why and how behind events. While the standard RAG framework is excellent for fetching facts based on semantic similarity, it fundamentally struggles with multi-step causal logic. The answers produced are often generalized, lack grounded detail, and fail to explicitly trace the cause effect dependencies present in the source document. This work, Causal RAG, proposes a novel solution to incorporate a causal graph directly into the RAG pipeline by constructing and tracing these causal uh, relationships. We aim to preserve contextual continuity, significantly improve retrieval precision, and ultimately provide more accurate interpretable, and causally grounded LLM responses. Talking about related work, uh, first of all, first the retrieval of augmented generation RAG, where most advancements focus on optimizing the retrieval flow or enhancing knowledge representation. Second, talking about causal graphs and RAG, while existing efforts like graph-based RAGs use general knowledge graphs, they often focus on semantic or thematic relationships. Causal RAG distinguishes itself by targeting explicit causal links. We are tackling the core problem of structural reasoning. Now, so let's talk about why regular RAG fails in providing accurate responses. Before presenting a method, it's crucial to understand why current RAG systems inherently fail in causal reasoning. Our analysis identifies two main categories of failure. First, as we see in limitations of regular RAG, context fragmentation. The process of document checking destroys the natural linguistic and logical flow, breaking up multi-sentence causal narratives. Semantic retrieval base Semantic retrieval bias. Retrieval relies solely on semantic similarity. This often retrieves information that is related to the query but is not on the causal part, leading to noise. And third is low precision. Regular RAG typically excels at context recall, fetching many documents, but suffers from low context precision, meaning the retrieved context is polluted with irrelevant checks, confusing the LLM. Now, rethinking graph-based RAGs, we know that while these methods improve precision, they often introduce complexity and do not inherently guarantee causal relevance. They prioritize community detection of summarization, not the mechanistic tracing of cause and effect. This analysis solidifies the need for a solution specifically focused on causality. So, coming to the methodology, to address these failures, we introduced the causal RAG framework, which works in three sequential steps. The number one is indexing. Our first step is to transfer the unstructured corpus into a structured causal knowledge base. We use a powerful LLM to perform two primary tasks: node extraction of key entities and variables, and directed edge extraction to identify explicit causal relationships. Every resulting node and edge is linked back to the exact textual snippet from the source document, providing essential provenance and grounding. The 4.2, discovering and estimating causal paths. This is a novel retrieval engine. Given a user query, we first perform an initial semantic search to identify a set of starting nodes. From there, we execute causal expansion, a graph traversal that traces ancestors and descendants for a specified number of steps. This ensures contextual continuity. The expanded subgraph is then refined by an LLM, which is tasked to construct the most plausible, compact, causal path relevant to the query. This process guarantees that we are retrieving a causally grounded subset of the graph. And the third step is retrieving context causally. In the final step, before generation, the refined causal part is used to precisely gather all the associated high fidelity source text snippets. This retrieved context is then structured into a powerful prompt for the element LLM. The prompt includes the user query, a linearized causal summary, and the evidence. By enforcing this structure, we ensure the LLM's generated response is both faithful to the evidence and coherent in its causal expansion. Coming to the experiment, the paper evaluates causal RAG against regular RAG and the state-of-the-art graph-based racks across several data sets designed for knowledge-intensive causal experiments. So coming to the experimental setup, our key evaluation metrics are designed to measure both quality of retrieval and quality of generation, answer faithfulness, like did the LLM hallucinate or was the necessary context retrieved, and context precision. Second is coming to performance comparison. The main results show a clear advantage of the causal RAG, while regular RAG had high recall but low precision, and graph-based RAGs balanced the two. Causal RAG achieved superior performance across all three metrics. Critically, it showed a significant boost in answer faithfulness, demonstrating its effectiveness in mitigating hallucination by enforcing causal grounding. So, coming to the case study, the qualitative case study further illuminates this, where baseline models produce fragmented, superficial, or even incorrect causal statements. Causal RAG consistently provided a complete multi-hop narrative tracing the entire cause and effect mechanism from the document to the answer. Coming to the parameter study analysis, we performed the paper performed a parameter analysis on the causal expansion step, demonstrating that the framework's performance is stable and tunable, allowing users to fine-tune the scope of causal search. And coming to the conclusion and future work, causal RAG is a highly effective framework that grounds the RAG process in explicit causal structure. By moving beyond semantic similarity, it provides a promising approach for knowledge-intensive tasks, delivering more accurate and interpretable responses. For future work, the paper looked towards optimizing the computational overhead of graph construction, potentially through implementing, updating, and expanding the framework to other forms of complex relational reasoning. Finally, the paper addressed a minor section on limitations. While highly effective, the framework's performance is inherently limited by the initial cost extraction quality, which is dependent on the robustness of the underlying algorithm. So, thank you. This is Ujjwal Jain.